The problem we will solve now will take us back to the early days where we were talking about the binary numbers and the binary system. What we want to do is to write a method, and that method will be inside a class. Suppose we name that converter. And this method will be converting the integer number, the decimal number that we give it, to its binary representation. We're also going to assume that this is a positive integer that we want to convert. A negative integer, if one supplies a negative integer or 0, we can just return something that is not really the representation. So what we want, for example, is if we provide the decimal 42, we want the method to give us back a sequence of zeros and ones, and that will be 1, 0, 1, 0, 1, 0 for 42 in particular. The first hint that I can give you here is that you can use a while loop to achieve that. If you would like more hints, keep on watching the video. Otherwise, try to solve this yourself and come back. Now let's see this example from our early days in the class, where we were saying how can we figure out the representation, the binary representation of a decimal number. And if you remember, the routine, the algorithm, is that we need to divide that number with the base of the system that we want to convert to. So if we want the binary representation, we need to divide by 2. So we divide by 2, and we keep track of what the remainder is. We keep on dividing until the result of the division is 0, the quotient is 0, and at that time we read from bottom to top all of the remainder values, and this is how we come up with the binary representation. So because the last remainder was 1, the leftmost bit will be 1, and so forth. See, here is the algorithm in words, exactly the same as we described with the example. We divide the number by the base, and then we prepend the remainder to the result string. After that, we will replace the number by whatever quotient the division gave us, and we will repeat until the quotient is 0. And this repeat statement is what should ring a bell in your mind that we need some kind of loop. So if you have not tried yet, try to implement this algorithm in code. Here is our class, the converter class, and our single method other than main. In main, we don't really do anything really new or very interesting. We just create an object of the converter class, and then we want to call this method the convertToBinary. We're calling it with 42. Now the method itself, we are just implementing exactly what we said in the algorithm. The first part is just taking care of the negative and the 0 case that we want. We said that we don't want our method to take into account, so we don't have to convert a negative or number or 0 into its binary representation. Although 0, what we can do is just return the string 0. So the algorithm is really implemented in the while loop, and what we do is just we repeat dividing the number that was given, which was n. We keep dividing by 2, and we see what the remainder is. Every time we get a remainder of 0, we prepend it to the result. Otherwise, we will prepend 1 to the result, because the remainder of the division with 0 will either be 0 or 1, right? And then we keep on dividing the number. Remember, this will only get the remainder. This is what will actually give us the division. The integer division will give us the quotient. And we keep on looping until the quotient becomes 0. Before we move on from this particular example, I would like to point out one more way that we could implement this algorithm in code, but the implementation would be a little bit different. We can check, is the number odd? If this is the case, then the low order binary bit will be 1. So we know what we can print. If the number is divided by 0, then, which is what the algorithm wants us to do, the bit to the left will now be the low order bit. So all we have to do in the loop is to go through the bits and shift right one bit at a time. Then we can test whether the new number is odd or even, and this way we can build the string backwards. Java provides actions, operations for bit shifting. And this shifting, since we only want here to shift right, can be the same as dividing the number by 2.